If you haven't seen part one to this video, I highly recommend going back and viewing that before continuing into part two. Part one covered a few different data points we use at the very tip of the iceberg of forecasting the aurora. And this video will focus on a few other things that we can kind of dive in depth and kind of get a better understanding for how to forecast the aurora by yourself. So again, we looked at our BZ numbers right here on the dashboard and also our HPI numbers down here on our ovation circle up here in the top right. If you want to learn more about those numbers and why they're the most important numbers, go back to part one and watch that. That's all I can really say. If you're not going to, well, it's not going to make sense if I continue on. So please go back and watch it, is all I'm going to say. Okay. Part two, we're going to dive a little more in depth this. Okay. So we learned about our BZ and HPI numbers and how that translated and how to view it and where that could be viewed in Michigan. We're going to focus on First off, we're going to focus on two other data points. Number one being solar wind speeds, which is going to be right here on your dashboard, and then density, which is going to be viewed in one or two different places depending on where you want to go to. So solar wind speeds right here, they do matter. Not as big as you may think, but they do matter. So again, the BZ and HPI is more important for a powerful aurora, but solar wind speeds, when they increase, they can cause aurora to be active. So the very bottom line of your solar wind speeds typically are around 3 to 400 on a normal day when nothing is happening in space. So when these solar winds increase to above, we'll say 450 to 500, that's when you start getting those active auroras being possible. So even with a negative BZ and solar wind speeds right around that 4 to 450, you can still have active aurora in Michigan. But when you get up and over 500 or so, that's when you really have better chances and start to increase your chances. The aurora that we saw a few nights ago here in Michigan on November 5th, 6th, around that time frame, solar wind speeds were only right around the mid to high 400s, so right around 450 to 475. We did not touch 500 the past couple of nights here in Michigan. So it just goes to show you that it is possible with lower end solar wind speeds, but again, the higher the better with this data point. The second thing I want to show you guys here is the density. Now, density you're not going to find on your SWPC dashboard. If you scroll down here, you're going to see the sun, CME map, the ovation model we looked at. We're going to see X-ray, proton fluxes. You're going to have estimated K-index. You're going to have the NOAA scales down here. Okay, you're not going to see density on a data point here. So here's where I'm going to go ahead and recommend something to you guys. If you guys have a smartphone, which I'm sure many of you do have, download the app, or if you don't want to download an app, you can go to the website. It's spaceweatherlive.com. You're going to pull up the dashboard. It's going to look like this. This is spaceweatherlive.com. This is by far the best aurora forecasting app out there. And I'm going to repeat that. It is the best out there. I am not positive. I actually don't think they offer alerts. I could be wrong on that. So if it does offer alerts, I would highly recommend downloading this, but I'm not sure if they do or not. But this is a good forecasting tool in real time. So if you scroll down here, a lot of ads on here. I apologize about that. I don't pay for anything. I'm not sure they offer a paid version, but I do have a lot of ads, so I do apologize. But when you pull up Space Weather Live, you're going to look at this. You're going to see this, should I say. Your KP index in real time. So the KP right now is KP3. If thresholds are reached, like if there is confirmed KP5, KP6, if there are storm level KP levels reached, it'll actually tell you down here underneath the KP3, it'll say threshold reached, and it'll give you a time. The time will be in Zulu time, so you may have to convert it as to when it was confirmed that it hit a certain point. But it will show you if that threshold is reached or not. Over here you have your ovation circle, which is a different look of what we looked at over here on this model. So it's a little bit more complicated to view on this particular one. So I highly recommend going back over to SWPC dashboard for the ovation model. If you scroll down a bit further, you have hemispheric power right here. This is your HPI, and just a different look at it. And also over here, your index forecast for KP levels. It'll tell you what's expected that night. Continue going down your live solar wind speeds, but here is where the data point will come in that we're going to talk about, and that's density. Your density right now is 2.46. That's on the lower end of the spectrum. For vibrant naked eye auroras, you want this number as high as possible. As much as 30 would be optimal. 30 and higher would be amazing. But typical aurora that shows up on only your cameras and maybe very faintly to the naked eye will start at around 10 to 15 on this density chart. So above 10 is good. When you get higher, 15, 20, it starts becoming better until you reach 30, when it looks like you're going to have that naked eye type of aurora storm. Now you're asking, can it happen with, like, 2, 3, 4, 5 below 10? I'm going to say, possible for maybe professional photographers. I'm sure it has happened before. There's a lot of data points that go into forecasting this. So with lower density, if some of the other data is higher than usual, it is definitely possible we could get the aurora still visible. But I'm just going putting out there the main data point you want to use, and that's going to be 10, 15, and higher, as high as you can go with the density. And density is basically just how vibrant the aurora is. And that is the dashboard here on Space Weather Live. They also have your BT field and your BZ field, just a little bit different look. It's more easier to read over here on the SWPC dashboard. Just gives you a number here. And that's really all you need. But those are the other two data points that we can cover now. Those are pretty much the four main data points that you use for forecasting. Now, if you want to get more advanced, we're about to dive into something called Stereo A and ACE satellites. Now, Stereo A is a satellite that orbits that is sometimes not in a good position to measure, but sometimes it is. And when it is in good positions to measure, we use this data quite frequently. Now, this satellite is approximately 5 to 8 hours. Again, 5 to 8 hours away from Earth. So data you see translating here is not live. It'll hit Earth within 5 to 8 hours. This is a good warning, type of advanced warning. We can kind of use this to say, oh, we have incoming ejection. It looks really good on Stereo A. We should see the effects here on Earth in the next 6 hours. And that's really as much time as we have to kind of view these ejections. Now, again, I'm going to highlight that Stereo A orbits, so you're not going to have accurate data 100% of the time. Sometimes it's offset. Like if you think of the sun and the earth on a straight line, sometimes Stereo A is off of that straight line. So it's not going to measure direct impacts at Earth 100% of the time. The other thing we can use, also just kind of giving you the overview, your BZ is your red line, your BT is your white line, your density is your orange, and your solar wind speeds are your yellows. And this will be translating over to the dashboard here, again, whenever that data point will reach Earth. So what you see on this map will translate over to the dashboard numbers whenever, whatever the delay is. Sometimes it's 5 hours, sometimes it's 8 hours. It can be in the middle. So the next satellite we can use is ACE. Excuse me. ACE is pretty much 1 hour. It's more accurate, and it's about 1 hour out from Earth. So what you see translating here is pretty much what you're going to see here on your SWPC dashboard. So data should be pretty much similar, if not identical, most times. So again, this red line here is your BZ, your white line is your BT. So pay attention to the white line. This white dotted line in the middle is your basically 0 point. Anything below that is negative, above that is positive. So we see now at the latest data point, the BZ is above that dotted line. That means it's positive BZ. That will hit the SWPC dashboard in about an hour or so, if not already happening. And we see that -1. So it's right around that, right around the same numbers as what you're going to see on the ACE satellite here. Again, density is in orange and speed is in yellow. So your density here, you have this 10, 1, and then 0.1. That's going to be your levels. Again, above 10 is optimal. So we see it's only hanging around right about 1, if not just a bit under 1. So not very good density happening right now. But your solar wind speeds are in between 600 and 700, sometimes reaching up towards 800. And we see that occasionally translating over to the dashboard. You see this number jump quite frequently. It's not uncommon to see these numbers jump. So, or should I say not jump, but just fluctuate in general. So that is your satellites and how to forecast the aurora. So if you guys learned anything, feel free to let us know what you learned. If you guys need clarification, feel free to drop a comment. Feel free to ask. We are an open book here. I'll be happy to answer any questions you guys might have. I know it's a lot of data here. It can be confusing. I'm sure it is confusing for most of you, but that is what we look at mainly for forecasting. We can make a separate video on how to forecast ejections themselves. We have a good tool here on Space Weather Live that we can look at different imagery of the sun. So for example, this CME, these are all CMEs, which are ejections that aren't Earth facing. So we go ahead and click the play button. We're going to actually pull up this imagery showing the ejection off the sun's surface. So we can go more in depth on a different video for this if you guys would like, but we have a lot of other data we can use. But those, what we just showed you, are pretty much the very basics of the forecasting of the aurora. So again, hope you guys learned something. If you guys need clarification, feel free to comment. We'll get back to you. And again, thank you guys for watching. Hit that like button on your way out. Thank you.